Hey guys, in this video I'm going to do the five problems that I assigned in class. This is a solutions video for those problems. For each of the following, find the equation of the tangent line at the indicated point. And you can confirm this by using your calculator at the end. So, to find the equation of the tangent line, first we need to find the derivative so that we can plug in our x value into the derivative to find the slope of the tangent line. Then we're going to use the given point to find the equation of the tangent line using point-slope form. So first, let's find the derivative. So f prime of x is equal to, and I'm going to rewrite this up here as to the 1/5 power. So f prime of x is equal to, we've got a chain rule here, or just a basic chain rule, 1/5, or basic power rule, so to say. Because chain rule is always in effect, 1/5, 3x to the third plus 4 x to the negative 4/5 times 9x squared plus 4, which is the derivative of what's inside. So keep in mind that this is a power rule. A power rule is still a chain rule since the chain rule is always in effect. So we did d outer and d stuff. Now we're going to do f prime of x just to clean this up. We're going to write this as 9x squared plus 4 all over 5 times 3x to the third plus 4x to the 4/5 power. So we cleaned that up. Now we're going to evaluate the derivative at 2. So f prime of 2 is equal to, if you do the math up there, that's going to get you 40. 5 multiplied by 2 to the third times 3 plus 4 times 2, and all of that, fifth root, then raised to the 4th power, is going to be 16. And our f prime of 2 is 1/2. So there's our slope of our tangent line. And yes, you are expected to do f prime of 2 without a calculator. That's part of the skill set you need to know in this class. So f prime of 2 is 1/2. From there, we're just putting it into point slope form. So y minus 2 equals 1/2 x minus 2 for our equation of our tangent line. Now let's move to number 20. For this set of problems, we are asked to find the points of horizontal tangency. So we're being asked to find an ordered pair where f prime of x is equal to 0. So that's our horizontal tangency. We're looking for points where f prime of x is equal to 0. So first we have to find f prime of x. And after we find f prime of x, we set it equal to 0. So to find f prime of x for number 20, we are going to be doing the product rule, because it's either a product, a power, or a quotient, and this is a product. So y prime is equal to the first times the derivative of the second, which is 2 parentheses x minus 4 raised to the first power times our d stuff, which is 1. And we don't need to write that because it's just 1. So first times derivative of the second plus the second times derivative of the first. Notice how the first is 2x times d stuff, which is x, so just 1. That's what we're saying, that the chain rule is always in effect. So the first times derivative of the second plus the second times derivative of the first. There's a times 1 here. And now we want to set that equal to 0. Well, let's clean it up first and then let's set it equal to 0. So when we clean that up, actually, you know what? Instead of cleaning it up, I see a GCF right here of x minus 4. I also see a GCF of 2x. Let's take that out. So y prime is equal to 2x x minus 4. There's my GCF. And what's left? Well, we pulled out a 2 and an x from here, so we're left with x. And we pulled out an x minus 4, so we're just left with x in this first piece. Now here we've pulled out a 2x and an x minus 4, so we're just left with plus x minus 4. All right, so again, we took out a 2, we took out an x, and we took out an x minus 4 from this two-termed expression or equation. And to finish that off, we've got y prime is equal to 2x multiplied by x minus 4 multiplied by 2x minus 4. And that all is equal to 0. So 0 is equal to all of that, which is perfect that it's in factored form because now we can see our x values for our horizontal point of tangency. We have horizontal tangents at x equals 0, at x equals 4, and at x equals 2. That's where this guy will be 0. And then we will plug these x values back in to our function to find their corresponding y values. So our horizontal points of tangency, or points of horizontal tangency, our points of horizontal tangency are 0, 0, 4, 0, and 2, 16. And I got those y values by taking our x values and plugging them back into the function. So let's do that with 22. Now for 22, we could just leave the plus or minus in there. So let's take the derivative, f prime of x. All right, the derivative of a constant is 0. So let's take the derivative of this guy over here, plus or minus 1/2, blah, 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 to the negative 1/2. So we did our big chain rule. I rewrote this as 24 plus 2x minus x squared. All of that is being raised to the 1/2 power. All right, so we've got 1/2, 24 plus 2x minus x squared, all raised to the negative 1/2. And with that plus or minus in the front, that's okay. So we did our d outer, now we want to do our d stuff. D outer, d stuff. Derivative of 24 is 0. Derivative of 2x is 2. 2, minus the derivative of x squared, which is 2x. We didn't do a chain rule to get this derivative. We just did straight up powers, simple power rules. So that's that. Now we want to just clean this up. So f prime of x is equal to plus or minus. On the bottom we've got 24 plus 2x minus x squared. All of that is raised to the 1/2 power. And in our numerator we have 2 minus 2x. So for points of horizontal tangency, we are setting f prime of x equal to 0. And when we do that, when we set this equal to 0, it's really just finding where the numerator is equal to 0 because the denominator will cancel when you go to multiply it to the other side. So f prime of x is equal to 0 when plus or minus 2 minus 2x is equal to 0. So there's my plus and there's my minus to get my two answers. So f prime of x is equal to 0 when the numerator is equal to 0 and plus or minus the numerator is equal to 0. So there's the first equation and there's the second equation. So for this one, x is equal to 1, and for this one, x is also equal to 1. And this is the plus, and this is the minus, so go ahead and plug 1 in for x using the plus to get your y value, plug 1 in for x using the minus to get your other y value, and we have 1, 2, and 1, negative 8. So check those out. You're going to plug 1 in and do negative 3 plus square root of da-da-da-da with 1 inside. And that'll give you the 2. And then you're going to plug 1 in, negative 3 minus square root of da-da-da-da with 1 inside to give you your negative 8. Let's take a look at 23 and 24 now. Below are the graphs of f of x and g of x. And for each problem we're finding h prime of 1. Alright, so let's find h prime of x. H prime of x is equal to 2. This is d outer times d stuff, which is f prime of x plus g prime of x. Okay, d outer, d stuff. So our 2 came to the front, f of x plus g of x raised to the first power, multiplied by the derivative of what's inside, which is f prime of x plus g prime of x. Now we're going to do h prime of 1. So h prime of 1 is going to be 2 multiplied by f of 1 plus g of 1 multiplied to f prime of 1 plus g prime of 1. Alright, so let's take a look at the graph now. We've got 2 multiplied by f of 1. f of 1, when x is 1, what is y? f of 1 is 3. g of 1, when x is 1, what is y on g of x? It is 2. Now f prime of 1. F prime of 1 is the slope of the tangent line at x equals 1. Well, since f of x is a line, the slope of the tangent line is basically the slope of this line, because if you draw a tangent on f of x, it is going to be the same slope because it's the same line, guys. So f prime of 1 at 1, let's see, what's our slope here? Down 1 over 1, so that's negative 1. So f prime of 1 is negative 1. Plus g prime of 1. G prime of 1, let's go to g prime. Let's go to 1 here, g prime of 1. And our slope at 1 looks like it's positive because it's going up. And it's going up 2 over 1 to get to the next point. So up 2 over 1, so that's positive 2. All right, and now we will do our basic arithmetic to get our answer of 10. So h prime of 1 equals 10. Look at all the work that I showed to get where I needed to go, but it is in this organized fashion. It follows a story. The story is easy to read and easy to follow. Now I'm going to clear this so I could do 24. Now 24, we are going to do the chain rule because you see the composition of functions, but it looks like our stuff has stuff. So instead of f of g of x, it's f of g of 3x. This is a really important problem that we sometimes tend to make mistakes on. So h prime of x, this is a chain rule, so be careful. This is double stuffed. So this is double stuff. All right, h prime of x is equal to f prime of g of 3x multiplied to g prime of 3x multiplied to 3, which is the derivative of 3x. So f prime of g of 3x multiplied to g prime of 3x multiplied to 3, which is the derivative of 3x. So d outer again, d stuff, or d outer, d first layer of stuff, d second layer of stuff. Because since it's not g prime of x, then we be multiplying it to 1, the derivative of x. It's g prime of 3x, so we have to multiply it to 3, the derivative of 3x. And now we plug in, so we are finding h prime of 1, so h prime of 1 equals to f prime of g of 3 times 1, so g of 3, times g prime of 3, because 3 times 1, times 3. And h prime of 1 is equal to f prime of g of 3 is 2, so f prime of 2. G prime of 3 looks like it's negative 2. Let's take a look at that g prime of 3. G prime of 3, let's go back over here. G prime of 3 is the slope of the tangent line on G at 3. So if we take a look at the slope there, it looks like to go from point to point, we are going down 2 and over 1. That slope is negative, down 2 and over 1. So that gives us that slope of negative 2 for g prime of 3 is negative 2. And f prime of 2, we already did it in the last question, but you could do it again. F prime of 2 is negative 1. So we've got negative 1 times negative 2 times 3 to give us 6 for h prime of 1. All right. So hopefully you went through all of those and were able to do those problems. Now I'd like you to do the next page, page 46, and do numbers 25 through 36, checking your answers, and be prepared to ask any questions about those in class tomorrow. See you then. Bye-bye.